I'm going to. And you can put my iPad. Oh, weird.
Oh my gosh. They know we win it. We went for two. It was an iffy play. But the fuss caps off year one as a national champion. And I'm looking at the progression after his first season. You see, still not enough overall. Speed stays the same, but a lot.
We're gonna make it work. All right. Let me grab my iPad and pull up the document. Anybody have any questions before we start? It's coming up. Like a lazy bone. 1 second. All right. So what we're gonna do today is we're going to go through the reactions that are on this document, alkyne reactions, and I'm gonna we're gonna walk through each one of these sentences, these steps. So what you see on the screen and what you see on the document is what we call a synthesis. Right, that's what you call it when you are making something, when you are doing organic, and you're trying to create a product or generate a product. It's called a synthesis. And a synthesis often happens in steps. Right. So I want to make it clear through these reactions that when it says one right here, after you do one on this starting material, you're going to get a product or an intermediate. And then whatever that product or intermediate is going to be the starting material for step two. I'm going to show you what I'm talking about when we go through this. But synthesis, I know we've talked about mechanisms, we talk about stepwise versus concerted. All of your synthetic processes are stepwise processes, but the mechanisms for each step may be stepwise or concerted, if that makes sense. So we're gonna let me cut this because I want to have plenty of room and work through each example. And if you have questions, you gotta speak them because I can't see the chat. So if anything you need to ask, you can just say it, unmute and say it. All right, so we're going to take that first reaction, A. All right, so A is, I'm going to take this, let me do it right. I'm going to take this alkyne, right? And I'm reacting that, no, it's sloppy. I'm reacting that with It's a two-step process. The first step is in a NH2, which is a base. All right. And in the second step, I'm reacting it with this. This is pH 2. That pH is simply an abbreviation for the aromatic ring. It's a way to abbreviate it to save space. And it's called a phenyl. We call that another name for the aromatic ring is a phenyl group when it's a substituent like that. Or when we abbreviate it as pH, we call it a phenyl group. So in the first step, this sodium amide is a base, right? And remember the other day we talked about the acetylenic proton having a pKa of about 25. So a strong base can pull that off. And so that's exactly what happens. So after step 1, right, I'm going to have this as my product. And I'll put the sodium out here because that's what actually happens. Sodium is negative, it's positive, and it's going to form a salt with that acetylide anion. We talked about this Wednesday. All right, so that's that plus NH3. Right, because it's the NH2 part of that, that's the base. If you write that out, actually, I think I will write it out. It's sodium plus, and then NH2 minus. All right, so that's my base. So it's just going to do a proton transfer, just like the acid-base reactions we've seen before. So now, after step 1, this is what I get. This is my main product, which is going to be used as starting material for step 2. So it's not the first thing, not the alkyne that I'm starting with in that second step. So I'm going to take for step 2, I'm going to take this, right? And I'm going to react it with this. Right, and this is a primary carbon. What does that mean for the acetylide anion if I react it with a primary carbon? What reaction is going to take place if the carbon is primary that I'm reacting it with? Anybody remember from Wednesday? Remember this, that mnemonic I gave you? 1 sausage, 2 or 3 eggs. What is the 1 sausage? What does that mean? Substitution. So this means that if you have a primary carbon, it's going to be substitution when you react it with the acetylide anion, and then if it's secondary or tertiary, you're going to do elimination. All right, so in this case, I'm going to do a substitution where this is going to attack that alkyl halide, and it's going to be a SN2 type substitution. That's SN2 type substitution. So my products are gonna be this. Right, and this is the CH2 that's here. Right, so this is the product where I have a bond now between this carbon right here and this carbon that was in the triple bond. And then of course, I'll put my hydrogens back in. Anybody not see that or have a problem with that? So it's just a SN2 substitution. And then what's left over, let me keep track of that too, is sodium iodide. That's negative, sodium is positive. All right. Questions about that? Any questions? So anytime you see those reagents in order like that, that means that every step is going to give you a product, and then the product from the whatever step that is going to be the start material for the next step. That's how that works. It's what we call a sequential reaction. All right, let's go. Let's do from A. So this is A. Now let's go down and do from A to C. Let's do that. So it's going to be A, which is this. All right, so that's what A is. And then I'm going to react that with the same set of reagents. This same thing, right? What's the product from that going to be? What do you think? That's the exact same reaction we just did to get to A. Is that right? All right. A was to go to A. We started with this alkyne, right? And then those were the reagents to get to A, which we said this is what A looks like in this final form, right here. So now I'm taking A and using that as the start material to get to C, which is right here. And these are the reagents. So what is C going to look like? And where's the reaction going to take place? Well, I'm using a base and I have this acetyletic proton right here that I'm going to pull off. So after step one, I'm going to have this. Right, I'll have this ring isn't going anywhere. This is CH2. It's C. And that's now negative. And of course, the sodium is positive. It'll be here. And then that's going to be plus NH3. Questions about that? Right, it's the NH2 that's going to come in and do the proton transfer here. Any questions about that? So after that first step, that's what I get, just like in the first reaction, that's what I had. All right. And then now I want to do step two, which is to react this with the exact same thing. So right? I'm gonna do this exact same reaction, and it's gonna be another substitution. So that's coming there. This is coming here. So now my final product after from A to C, this is what C is gonna look like. So I'm gonna have this. Not sure why there's such a lag in there. Anybody not following or stuck or nervous or intimidated? Say something. And do you see how that's the product? If not, say something. So to go to A, we did that, and then now we went, so A became the start material for C. So we just reacted that again under similar conditions, and this is what we got. Questions? You see it? Anybody not see it? All right. Do you want to take C to D and just finish this out, or would you rather do A to B? That's the question. Let's finish this. I think that's the easiest route to finish it. So now we're going to go from C to D, which is right here. What does this do to a triple bond? Lithium plus ammonia. I gave you a mnemonic for that too. Right? This is what you see right here is a reduction method. Right? It takes the alkyne to an alkene. But the question is, what type of alkene? Is it cis or trans? Because there's another reduction, a set of reduction reagents that can give you cis, and that's one that can give you trans. All right, let me help you out because it's Friday and everybody's quiet. So Lindlar's catalyst will give you a cis alkene. Ammonia, that's what the A is. So L is for Lindlar's and A is for ammonia. Right? Remember I gave you that mnemonic. Little children always tripping. Right? LCAT. So Lindlar's is cis, ammonia is trans. So lithium and ammonia, when you treat a triple bond with that, you're going to get a trans double bond. So let's do that. So let's take the product right here. We're going from C to D. All right, so I'm gonna just draw this out. So this is my triple bond. Both sides have the same substituent. Over here is the same thing on that side because that's what we made. All right, and I'm gonna treat that with lithium, come on, pen, and ammonia. And that's gonna be a trans alkene synthesis. Right? So what would that double bond look like? What would the alkene look like? We know it's going from a triple to a double, right? Because that's what that set of reagents does. But what does it look like when I say trans? Opposite side. Okay. So my product is going to be a double bond. Looks like this. I'm going to put the hydrogens in first because that's the easiest thing to do. And then this is going to be like so. The other side is going to be like so, right? A trans alkene. Any questions about that? So I took C, which was the alkyne that I made from A, right? After I made A, and then now I'm taking C and converting it into D. That's what this means right here. So whatever C is, I'm reacting that in the presence of lithium and ammonia to give me D. So this is what D looks like. It's a trans double bond. Good. Questions? Any questions about that step? All right. Let's finish D to E. Let's do that. So D to E. It's gonna be that trans double bond. I'm just gonna copy it here. And then this is in the presence of ozone, followed by zinc metal. I think that's what's up there. So that's in 2 steps though. And acetic acid. What kind of reaction is this? This time I'm starting with an alkene. And I'm treating it with ozone and zinc metal. What reaction is that we learn from reactions of alkenes? Ozonolysis. Excellent. Which does what? You got your notes? Better look for it. It breaks the double bond and turns spell today. Oh. Right? It converts alkenes into carbonyls. Right, so remember when I talked about this, I said that you could think of this as the alkene getting cracked in half. And then both sides of the alkene, if you bless you, I think. Both sides of the alkene becoming a carbonyl. Is that right? So the kind of a shortcut way of thinking about that is to stick an oxygen on either side of that divide to see what your products are going to be. So you're going to get 2 of the same products. I'm gonna draw it, I'm gonna write it out like it's drawn. So this is O H. H2. And then here's my aromatic. And then the other carbonyl looks like this, right? It's the same, but it's just on the other side. I promise you can hear a rat pee on cotton here. It's so quiet. This is too quiet. All right. Any questions about that? So now we took the alkyne that we made down to an alkene, and then we went back and pulled the reaction from when we were studying alkenes, and we used that on that alkene to make 2 carbonyls. All right. Questions, comments? If you are stuck or still writing, say something. It's a lot to take down, especially when I cheated by copying the first part. All right. There's only one reaction left, I think. Let's go back up top. and it's here. So we're taking A, which we made down here. Right, and we're gonna treat it with H2 and Lindlar's catalyst, followed by oxymercuration. What is H2 and Lindlar's catalyst gonna give on a triple bond? What does it do to the triple bond? Lindlar's catalyst.
Would it break it?
Say that again.
Would it break the triple bond?
And yeah, it is gonna break the triple bond in a second. But it's gonna turn the triple bond into a double bond, is that right?
Yes, so like to an alkene.
Yes, it's gonna take it to an alkene. So let's draw that first, cause that's the first product from,
If it's it,
I just turned it on, work,
the subtle and the ball wasn't here.
working now. Yeah, so we're gonna take the alkyne down to an alkene. I'm gonna draw that. This is not B. This is not the final product. This is the starting material for the second step, for the oxymercuration step. So this is gonna be CH. Come on. Like that. And now this is a right, an alkene. So now this is what 2 and 3 is gonna act on. So what is the result of steps 2 and 3? These kind of go together, right? Because this is oxymercuration. Is that right? So what is my spelling off today? Duration there. No mind. What does that do to alkenes? Okay. So it adds, so it does add mercury, but there's also like I guess the final outcome is adding water, right? OH to one side, H to the other side. What's the regiochemistry? Is it Markovnikov or anti-Markovnikov? That's the key to the reaction. Markovnikov. So when I take this double bond and which is the product of step 1, and I do oxymercuration, which is steps 2 and 3. Right? I'm going to get out an alcohol. And it's going to be on this carbon because it's Markovnikov regiochemistry. Right? So that's what steps 2 and 3 are to get to B. So B, the final product for B is this. All right, any questions about that? So we can go back and kind of paste this in up here. Right, we say that this was, where's A? This is A. I'll paste them into the box up top. This was A. Right? And then B, we just did. So B, the final product for B is this. that right? Now, what do we have? What was C? C was all the way down here. This was C, is that right? Yes. Put that in the box for C. Still picked up that hydrogen. And then D was here, is that right? The trans alkene. And then product E was the ozonolysis product, so. Here, these two aldehydes. All right, questions about that, about anything we did? All right, so this is this is an example of a couple of things. Number one, we're going through the different reactions of alkynes that we talked about. But number two, it's also a good way to illustrate how synthesis happens, right? When you're doing organic chemistry. All right, you never just go into the lab and just start throwing stuff in a pot or in a flask. You always go in with an intention. Everything is intentional, including which reactions you use to get which products and so on and so forth. Questions about anything with alkynes? All right, questions with anything about alkenes? Question about whether or not I'm gonna let y'all go early. Which I am, because it's Friday. Y'all are burned out. Everybody's quiet. So we're gonna stop here. I'll post an announcement later regarding a bunch of stuff, including the final and a whole lot of other information. So make sure you read that thoroughly, and we're just gonna go from there. All right, all hearts and minds clear? All right.